Hello, my name is Advik Prabhu, and today, in this lesson, we are going to learn about Venn diagrams and how to count multiple events. This is lesson 3 of our combinatorics course. So our first question is, at Brown High School, there are 12 players on the basketball team. All of the players are taking at least one foreign language class. The school offers only Spanish and French as its foreign language classes. 8 of the players are taking Spanish and 5 of the players are taking both languages. How many players are taking French? Pause the video, try it by yourself, and then unpause it once you think you have solved it. 3, 2, 1, and go. So, how do we start this? Well, let's think of a Venn diagram. A Venn diagram is a really helpful tool for counting. It looks something like this. Let's call this side Spanish, this side French, and the middle is both. I'm not going to write that. So there are 12 players total. Okay? And we got 8 players are taking Spanish and 5 players are taking both. 5 players are taking both. So we know that. 8 players are taking Spanish. So that means there's 3 people taking just Spanish. And there's 12 people total. So that means there's 4 people just taking just French. And that means that there are 9 people total that are taking both languages. Okay, now let's see a different problem. There are 30 students in Miss Taylor's kindergarten class. If there are twice as many students with blonde hair as with blue eyes, 6 students with blonde hair and blue eyes, and 3 students with neither blonde hair nor blue eyes, how many students have blue eyes? Well, now this seems harder. Well, let's try a Venn diagram still. So we got blonde hair, blue eyes, okay, and let's put this entire thing in a box. And then there's neither, which is going to be outside. So there's 3 students with neither of all of them. And there are 6 students with both. Okay? Now let's just call this x and call this y. So now we can create equations. So we got, there are twice as many students with blonde hair as with blue eyes. Or x plus 6 is equal to 2 times y plus 6. Okay? And we got all of them add up to 30. So 27 inside this, because there are 3 outside. So that means x plus y plus 6 plus 6 is equal to 27. X plus y is 21. Or y is equal to 21 minus x. This gives us x plus 6 is equal to 2 times 21 minus x plus 6. This gives us x plus 6 is equal to 42 minus 2x plus 12. Or 54 minus 2x is equal to x plus 6. This gives us 3x is equal to 54 minus 6, which is 48, or x is equal to 16. Now we got that x plus 6 is equal to 2y plus 6, or we can do something simpler. This entire thing is 27, which means that there are 5, and that would be our answer. How many students have blue eyes? 11 students total have blue eyes. Okay, let's go with a different problem. Suppose I have 6 shirts and 5 ties. How many shirt and tie outfits can I make? Well, 6 shirts and 5 ties seems kind of simple, so let's see if we can make a table for it. Okay, shirt number 1, shirt number 2, shirt number 3, shirt number 4, shirt number 5, all the way to shirt number 6. Then we got tie number 1, tie number 2, tie number 3, tie number 4, and tie number 5. Now, we're not going to write in all of these, but we can see that all of these are possible outcomes, and that there are 6 times 5 possible outcomes. So that means there are 30 total possibilities. In how many ways can we form an international commission if we choose one European country from among 6 European countries, one Asian country from among 4, and one North American country from among 3, and one African country among 7? Now this seems kind of hard, so let's go back and try to generalize this process. So we have, right now we got 6 times 5, and we might notice that 6 was here and 5 was there. So maybe multiplying them creates the number of total possibilities. That would make sense. We have a table with 6 rows, 5 columns, and there are going to be 30 boxes total. So let's try doing that. Now we have a table. We can have 6 possibilities for European countries, 4 for Asian countries, 3 for North American countries, and 7 options for African countries. Let's see what we got. 6 times 4 times 3 times 7. 6 times 4 times 3 times 7. Well, let's try simplifying this. 7 times 6 times 4 times 3. 42 times 12, which is equal to 504. So that means there's 504 different possibilities. And this was a lot easier than writing the table. So now we can see if we have events, we can just multiply them. So how many different ways can I order 4 books on a shelf? Now, this is easy, right? Like 4 options, 4 options, 4 options, 4 options. But the problem is, this is not the answer. This would be 4 to the power 4, which is equal to 256. But this isn't the possible answer, because once you pick the first book to go in one spot, the second book can't be the same. So now we actually, for the first one we have 4, but the second one we only have 3, because one of the books have already been taken out. So now we'd get something like this, which is not equal to 256, but it's actually equal to 24. So that would mean 24 is our answer. So let's say we have a math club and it has 20 members. How many ways can it select a president, a vice president, and a treasurer if no member can have more than one office? Well, we have 20 members, so how many presidents can there be? There's 20 possible presidents. The vice president is everyone except the person who's a president, so 19, and treasurer 18. So what is 20 into 19 to 18? If you compute it, it comes out to 6,840. So that's how much ways there can be. And now let's try generalizing this problem. How many ways can we arrange n different books where n is a positive integer? Well, this is like a generalized way to do this. So there are n choices for the first book, but then once you place the first book, there are n minus 1 books remaining. So there are n minus 1 choices for the second book. So it looks something like this. And then the next one, once you place that, you have n minus 2 books. And this goes all the way down until you have 3 books, 2 books, and finally 1 book. Now, this answer is like really long. Like trying to write this all out is a lot of work. Like remember like multiplication, if you write 4 times 4 times 4 times 4, you just shorten that to exponentiation. But is there a way to do that for this? Well, something like this where you multiply numbers decreasing by 1 occurs so much times that we just have this fancy symbol for it. And this is read n factorial and spelled like this. So 3 factorial, or actually let's go 4 factorial because it's an answer from earlier, is equal to 4 times 3 times 2 times 1, or 24. So now let's try to get used to factorials. Well, let's try computing on each of the following to see if you understand it. 9 factorial over 8 factorial. This is equal to 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 over 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And we might see that basically all of this cancels out. And you just are left with 9. Let's try simplifying this, because that was a lot of writing. If there was a faster way to do it, you would really want to do that. So you might notice that that second part of the equation was just 8 factorial. So we got 9 times 8 factorial, which is 9 factorial, over 8 factorial. And now these two would just quickly cancel out to leave 9. So our answer to A is 9. Okay, now 42 factorial over 40 factorial. 42 factorial over 40 factorial. Now we can try doing the same thing as earlier. 42 times 41 times 40 factorial over 40 factorial is equal to 42 into 41. 42 into 41 is equal to 1722. So that's our next answer. Okay, now what is 8 factorial minus 7 factorial? Now, this seems something that would be a lot easier just to write. Like, I don't want to find cool ways to do this. So let's just see. If you brute force this, you would get 8 factorial as 4. We would get 8 factorial as 40320 minus 7 factorial, which is 7 factorial, which is 5040, and that would lead to 35280. That's one way to do it. Another way to do it is you factor it out. 8 times 7 factorial minus 7 factorial, or if you factor it, 8 times 7 into 7 factorial, so 8 times 1 into 7 factorial, which is 7 times 7 factorial. And if you multiply out 7 times 7 factorial, you would get 35280. So that would be 35280. And that basically summarizes all of it. So we learned how to use Venn diagrams in these problems, and then how to multiply numbers to count, and finally factorials and cool factoring tricks you can use to simplify problems with them. Thank you for listening, and bye.